Hi, my name is Paul and I'm an engineer at NI. And as part of the Power Management IC validation solution, how to video series, I will showcase the hardware that is being used in the demo. So let me start with the diagram. So that is shown here. That is my current hardware setup for my power management system that I'm using. And I would recommend using these DUT connections as a reference for setting up your own device, right? So if you're setting up your own device that you're going to test, the only side you would need to change is the DUT side, assuming you're using the same hardware and you're using the open source GitHub example that I talked about it in my last video. So first, let's start. I'm using the PXI chassis, the PXIe 1095. So that's the first hardware that I have. Next, I have is embedded controller PXIe 8881. And then for my first module is the PXIe 6571, which is shown on the bottom left corner, and that is the digital pattern instrument on this diagram, which is used for I2C communication in my case. Obviously, you can do other type of communications, but that is controlling the DUT registers. And then on the PXIe 6571 side, I'm using the following connections. DIO 0 to SCL, and then DIO 1 to SDA. And for my second module is the PXIe 4151, which is the programmable power supply, which is on my upper of the screen, or the middle of the screen. And this is capable of 300 watts of power supply. And one thing to note for the setup, that can also be stacked or gang for up even more current voltage by connecting these in series or in parallel. And there's also open source example available, as I talked in my last video, for ganging as well. Now on this PXIe 4151 side, I'm using the following connections. So high to VIN, and I'm using sense high to VIN sense, low to ground, and then sense low ground, sense low to ground. And my third module is the PXIe 4051, which is an electronic load module. And that provides essentially the programmable load capability of syncing DC power. And on the PXIe 4051 side, I'm using the following connections. So I have the high to Vout 0 and Vout 1. I have sense high to Vout 0, and then a low to ground, and then sense low to ground 0. So there are additional modules shown on this diagram, as you can see, as an options. For my case, I was not using oscilloscope, but you can easily add oscilloscope if you need even higher speeds to measure some transients, some other fast moving data. It's easily can be connected and interface with Insight Instrument Studio Pro. And then you can connect third-party instruments and create a plugin, just like we are running plugins that I was showing from the open source. You can create a plugin for third-party instruments, so you can run your third-party instruments, have that synchronized and run in parallel with the NI instrumentation if needed. At this point, I like to highlight some of the important features for the hardware that is used in the system. So first, I want to start with the PXI platform. So PXI platform, as I have it here, which is begins with the chassis and embedded controllers. So PXI chassis are designed with automated test and measurements in mind, and that can provide the following features, right? So you get very high throughput capabilities. You get really good, accurate synchronization capabilities. Obviously, there's, for this particular solution, I'm only talking about 3 modules, but you have over 600 PXI modules available. So as you grow, as you scale, you can easily add, change, and swap things as you need. And then it leverages the open architecture, so you can develop your own applications using NI's LabVIEW, Python, or other languages. And as per my last video, right, we have the open source examples for you to get going very quickly with power management validation. Okay, so second is the PXIe 4051 and PXIe 5151, the high performance 300 watt power modules that are great for power electronics validation and test, and just general semiconductor and electronics test, and with additional benefits, right? So the additional benefits for PXIe 451, uh, which is the power supply, is a single channel dual slot, and it can handle up to 20 volts and 25 amps. And for PXIe 4051, the E-load, it's a single channel, 3 slot, and it can go up to 60 volts and 40 amps. Then there's obviously common features such as this isolation. You have the simultaneous measurement capability. You have high accuracy with these instruments. And we have a very fast sample rates of 1.8 million samples per second. We have transient response tuning with the source adapt technology. So by the way, for anyone new to source adapt, what it is a technology which fundamentally essentially addresses the issue of addressing range of loads by helping you custom tune the SMU response to a given load. So this provides essentially an optimal SMU response with a minimal settling times, which leads to a shorter wait times and faster test times. And it eliminates the overshoots that you would normally get to protect the device under the test and oscillations to ensure the system stability. So it's a great way to get even better readings. And then you have advanced sequencing available, and then obviously these can be connected in series or parallel to get even more power if needed. So third is the PXIe 6571, which is a digital pattern module for semiconductor validation characterization and production tests, and it comes in actually 3 flavors. I have 2 flavors shown. The third flavor, it's more rough applications, but there's a dual slot available as well if interested. For these, I'm recommending these 2 modules, which is the 8-channel version. The 8-channel is a single slot. It's supported both 58 watt and 82 watt chassis, and then timing specifications are typical, versus the 32 channel is also a single slot, but it's supported in 82 watt chassis, but the timing specifications are warranted. So if you need that extra accuracy and warranted timing specs, that's the module that would be used for. Now, there is common features, so essentially the clock rate and max data rate is same for both modules, which is fantastic. Obviously, we have the same APIs, support for LabVIEW, Python, and C#.NET. And of course, for my open source GitHub example, I was using this module with the semiconductor device control. So this is what controls and communicates with my DUT. So this is the last module I want to talk about it. So this covers all the hardware and connections that I'm using for my power management validation demo. As always, refer to the latest specs for all modules to ensure proper connections. But this video is meant for you to show the connections. So if you're following along, you can just change the connections to your DUT. If you have the same modules, you can use the code and you can get going within an hour or 2 with this example. Again, thanks for watching, and see you in the next video.